So now that you know how to display the answers to inequalities, now we have to actually get those answers. So it's no different than solving a linear equation. The only difference is what you get for your solution. So for example, if you have an equation like x minus 5 is greater than 1, you just treat this like an equal sign. So we can use the addition property of equality and say that if I want to get rid of this minus 5, I could add 5 to each side of the equation and it wouldn't change the equation itself, right? I'd be left with x is greater than 6. Cool. So what that means is that any value greater than 6 is going to make this equation true. Okay, well let's show that as set notation, which is this guy, but also give the solution set, this guy, in both interval and graph forms. So they want you to visually show what the solution is. So if I was to graph this, I only have one variable, so I just need one axis. So I've got my x-axis here. I'm going to put a 6 somewhere on the x-axis, and then I'm going to show that x can be any value greater than 6. Now greater than 6 is all the numbers to the right up to infinity. And then since it's greater but not equal to, I'm going to use a round bracket opening to the right. So this is my graph form. And then from the graph form, I could pull off my interval notation. So I'm going to go round bracket 6, and then where is it going to? Infinity. And infinity always gets a round bracket, because how can you be equal to something that you don't know what it is? So again, interval notation is just the graph without the number line part of it. So you're always looking, where's my number going from, where's my number going to, and then what brackets should I put? Always, always, always make sure in interval notation that these are in numerical order. I see lots of times on tests people put infinity to 6, but that's not true. Like on a number line, infinity isn't to the left of 6. So you have to put it in the order that it appears on the number line. Okay, this next equation. So for this one, the first thing I have to do is isolate my x term. So I'm going to put the x terms on one side. So I'm going to minus 4x from each side. I hate that my 4's always turn into 9's. So I end up with x plus 3 is less than or equal to negative 1. Then I'm going to isolate my x by minusing 3 from each side, and I end up with x is less than or equal to negative 4. Again, this is my solution set. So now I have to show it in interval and graph form. So again, the graph, all I do is show a number line. I put that negative 4. I always put it right in the middle. It does not matter. It's just to get the picture. Now this time I'm less than or equal to negative 4, so I'm going to open to the left and show that it's going all the way down to negative infinity. So for my interval notation, I would start at negative infinity and I'd go up to negative 4 with a square bracket. Awesome. Now, the next property that we're going to use is the multiplication property of equality, which is that you're allowed to multiply both sides of the equation as long as you multiply them by the same thing. This is the only thing that varies a little bit from equations, because if we have an inequality, like negative 2 is less than 5, this is true. If I were to multiply both sides of this inequality by 8, would the inequality still be true? So for example, 8 times negative 2 is negative 16. 8 times 5 is 40. Is this still true? Is negative 16 less than 40? It's true. So it's all good. I'm allowed to multiply by 8. But if I did the same thing, but instead of multiplying by 8, I multiply by negative 8, will it still be true? So negative 8 times negative 2 is 16, and negative 8 times 5 is negative 40. Is negative 16 less than negative 40? No, this one's false. So there is a break in the rule, which is that you're allowed to use the multiplication property, but you're not allowed to multiply by a negative unless you reverse the direction of the inequality symbol. So if I had taken this negative 2 is less than 5, and if I was to multiply it by negative 8, if I switch the sign, then it will maintain its equality. So now I would get 16 is greater than negative 40, and now it's true. So the rule is that any time you multiply or divide, because dividing is just multiplication of a fraction, both sides by a negative number, you have to flip or reverse the inequality sign. So I've got 4 questions here. It says solve each inequality, give the solution set in both interval and graph forms. My question to you is, do I or don't I? Okay, do I flip the sign or don't I flip the sign, the inequality sign? So for this one, to get x by itself, I'm going to divide by 2. Because it's a positive 2, I don't need to touch the inequality. I get x is less than or equal to negative 2, which means that if I plug in any value less than or equal to negative 2, so if I was to show this on a graph, I'm looking at anything down here. I should have just taken, I think I'll just take this off in the future. We don't need to do that, so we're just going to solve the inequality. So if I say that any value less than or equal to negative 2 should make this true, it means I could check something like x equals negative 3. So 2 times negative 3, is that less than or equal to negative 4? Yes, I'm good. Okay, what about this one? So this one, to solve for x, I'm going to divide by negative 2. Should I or shouldn't I? Well, I should. Should flip my inequality sign. Okay, if I flip my inequality sign, I get negative 2 divided by negative 2 is just x. Negative 4 divided by negative 2 is 2. That means that any value greater than or equal to 2 should make this inequality true. So let's pick something like x equals 3. Negative 2 times 3, is that less than negative 4? Well, negative 6 is less than or equal to negative 4. It's true. But it's only true because I flipped my sign. If I hadn't flipped my sign, it wouldn't be true. Okay, so what about this one? For this one, I need to get x by itself. I'm going to think of this as negative. Well, actually, I shouldn't. Let's just do this. I'm going to think this is x divided by negative 2. Some people like seeing it like that better, right? So negative 1/2 x is the same as x divided by negative 2. Really good to be able to see it both ways. So to solve this, I'm going to multiply both sides by negative 2. I mean, you could divide by negative 1/2. I feel like it makes things more complicated. So I'm going to multiply both sides by negative 2. Should I or shouldn't I? I should. So I'm going to flip my inequality sign. I'm left with x is less than or equal to negative 8, which means any value less than or equal to negative 8 should make my inequality true. So let's pick negative 10. Negative 1/2 times negative 10, is that greater than or equal to 4? Well, negative 1/2 times negative 10 would be 5, so it's true. But only because I flipped my sign. If it was the other way around, I would have been picking a value greater than or equal to negative 8, which wouldn't have worked. Okay, and then lastly, this one, to get x by itself, I'm going to multiply both sides by 2. I get x is less than or equal to negative 8. So same as this guy, so let's check negative 10. I get negative 10 divided by 2. Is that less than or equal to negative 4? That's negative 5 is less than or equal to negative 4, which is true. So again, when do I, when don't I? Only if you multiply or divide by a negative number. All right, so now let's solve each inequality. So using our rules, we have to decide whether we do or whether we don't. And then we're going to give the solution set in both interval and graph forms. So for this one, we're going to add 3 to both sides. We end up with 4x is less than 8. To get x by itself, I'm going to divide by 4. Because I'm dividing by positive 4, nope, just leave it. So this is telling me that x can be any value less than 2. Less is to the left, round bracket, because it can't be equal to. Where's it going to? Negative infinity. So my interval notation would be negative infinity to 2. And again, if I wanted to plug in a value, I could pick something like 0 or 1 and just make sure that this inequality is true. This is the one where it's really a do I or don't I, and it's going to depend upon which side you put your x's on. So I'm going to say pause the video and give this one a go. So I'm going to solve this one twice. So I'm going to solve 3x minus 5 is greater than or equal to 5x plus 3. And I'm going to solve 3x minus 5 is greater than or equal to 5x plus 3. Okay, the first time I do it, I'm going to do it the way most people like, which is x's on the left, numbers on the right. So I'm going to minus 5x from each side. That's going to leave me with negative 2x minus 5 is greater than or equal to 3. I'm going to add 5, add 5. I get negative 2x is greater than or equal to 8. Then I'm going to divide by negative 2. Because I'm dividing by negative 2, I have to flip my sign. That's going to leave me with x is less than or equal to negative 4. Method number 2 is that instead of being stuck on x's with the left, I'm going to move them to the right so that I don't have to deal with a negative coefficient. I'm going to minus the 3x and minus the 3x. I'm left with negative 5 is greater than or equal to 2x plus 3. Then I'm going to minus the 3 to put the numbers on the left. I get negative 8 is greater than or equal to 2x. And then I'm going to divide both sides by 2. Because it's positive 2, I don't have to flip my sign. But you'll notice this answer is the same as this answer. If I rewrote it the other way, the smallest part is near the x. It's exactly the same. But I didn't have to flip the sign because I didn't have a negative coefficient on x. Regardless, my answer is that x is less than or equal to negative 4. So I'm going to put a negative 4. I'm going to show that less is to the left. I'm going to use a square bracket because it's equal to. Where is it going to? Negative infinity. So my interval notation would be negative infinity to negative 4 square bracket. All right, go practice a few.